When you think about a chemist at work, you're probably imagining a lab full of dangerous chemicals and expensive glassware. However, in my lab, we do chemistry in a different way. We use computers to simulate nuclei and electrons, the fundamental particles that form atoms and molecules. And we do this to learn how chemical reactions work. How do we simulate molecules in a computer? Think of a game like Angry Birds that has birds, pigs, and other things flying and colliding with each other. Now all of this looks very realistic, and that's because the computer program behind the game is essentially simulating the laws of classical physics. The same laws that govern how large objects move in real life. In our research, we do something similar, but instead of simulating birds and pigs, we simulate tiny objects, electrons, and nuclei. These microscopic particles are difficult to study because they obey a more complex set of physical laws, those of quantum mechanics, which are challenging to simulate with computers. Now, in my group, we developed new methods to simulate molecules, and we use them to study how chemical bonds form and break, and what happens when molecules interact with light. These tools help us predict the properties of molecules and how they react, and in doing so, we can actually see what the electrons are doing during a chemical reaction. We also use simulations to study molecules that easily break apart and are difficult or even impossible to probe with experiments. An important part of my research is also writing the software that can perform these simulations, which we share for free with other researchers. I would say that the most fun part of my research is that it falls at the intersections of many disciplines: chemistry, quantum physics, computer science, and applied mathematics. My name is Francesco Evangelista, and I'm a chemistry professor at Emory University.